Good morning. Welcome and thank you for joining this webinar on energy efficiency in buildings with a special focus on technologies and policies. This presentation is based on IEA's ongoing work and research in this area, as well as IEA's collaborative work with SENER and CONUEE on space cooling and enforcement of building energy codes in Mexico. The webinar is organized by the International Energy Agency with the kind support of the Secretaría de Energía. And my name is David Morgado, and I'll be moderating the webinar. I'm joined today by my colleagues and presenters, Brian Dean from the IEA's Energy Efficiency Division, and John Dulac from the IEA's Energy Technology Policy Division. Before we start, I'll go through the agenda for today. We'll have general introduction, welcome remarks also by Santiago Crujeras, Director General of Eficiencia y Sustentabilidad Energética from SENER. And then we'll go into the presentation providing an overview of energy efficiency in buildings, then looking at technologies, policies for energy efficient buildings, and also looking at some of the work that IEA is doing on energy efficient buildings with the technology collaboration programs. Then finally, we'll have some time for questions and discussion. We would really like to hear from you and would like to include your voice in the conversation, so please ask questions and share comments so that we can discuss these at the end of the webinar. To do so, before we start the webinar, we'd like to go through the setup of the webinar and let you know how you can participate in today's session. The slide shows you an example of the attendee interface. You should be seeing something that looks like this on your computer. You joined today's webinar listening through your computer speaker system by default. This means if you can usually hear music on your computer, you'll be able to hear the presentation. If you'd like to call in using the telephone, you just locate your audio pane and select Use Telephone, and then the dial-in information and access code will then be displayed. The number and access code are indicated on this slide. If you also have the ability to ask questions using your questions pane. So simply type in your question, either in English or in Spanish, and click Send. At the end of the presentation, we will have some time for discussion, and we'll go through the questions you've submitted during the presentation. Please note that we'll be recording the webinar. We'll make a link available for those that have missed the webinar, as well as if you want to share it with colleagues or would like to go over it again. So unless there's any questions at this time, if not, then we'll proceed with introduction speech by Santiago Crujeras, Director General de Eficiencia y Sustentabilidad Energética from SENER.
Good morning, everyone. Muy buenos días a todos. It's a great pleasure to have one more webinar. La verdad nos da mucho gusto que podamos tener un webinar más. Cada vez tenemos más personas que se suman a esta nueva práctica que hemos iniciado conjuntamente la Secretaría de Energía y la Agencia Internacional de Energía. Hay casi 200 personas participando en este webinar esta mañana. En nombre de la Secretaría de Energía quiero agradecer a David, a Brian y a John por el apoyo para poder organizar este webinar con la agencia, sin duda a Ana Lepur, quien es la representante de la Agencia Internacional de Energía en México. Y bueno, la reunión de esta mañana nos une precisamente porque el tema de edificaciones sabemos que es un área de oportunidad muy grande en nuestro país. Es un área en donde consideramos que la eficiencia energética puede servir mucho más como herramienta para el aprovechamiento sustentable de la energía. Quiero compartirles también que la Agencia Internacional de Energía ha creado una división específica en materia de eficiencia energética, precisamente por la importancia que tiene la eficiencia energética en el mundo. Y el caso de México, pues es muy especial en este sentido porque hay un compromiso bilateral muy importante entre la agencia y México con miras a desarrollar aún más la eficiencia energética. Hace más o menos 2 semanas presentamos el primer código de edificaciones aquí en México con el apoyo de CACEDI, de CTS Embark, con el apoyo de la CONUEE, sin duda, del gobierno británico, de la Agencia Internacional de Energía. Y el hecho de que exista este tipo de acciones, este tipo de elementos que van conformando una política, es lo que va haciendo que realmente se puedan ir dando resultados en el corto, mediano y largo plazo. Así que con ello, una vez más, agradezco la oportunidad y el apoyo de la agencia para poder celebrar estos webinars. Creo que se está volviendo una práctica muy importante, tanto para nuestro país como para otros países en los cuales esto se está replicando también. Y estoy seguro que vamos a poder aprender mucho esta mañana sobre cuestiones de política y tecnología. Once again, David, Brian, and John, thank you so much, and all the best for this webinar. Let's get started.
Thank you, Santiago, for all your support in organizing these webinars. We just have more than 200 people joining us today, and it's definitely a record here at the agency, so we're very, very proud of organizing these webinars with SENER. Without further ado, I'll pass on to my colleague, John Dulac, and he'll start the presentation on energy efficiency in buildings. Thank you.
All right, thanks, David, and good morning, everyone. Buenos dias. A big thanks to David and Santiago for their introductions. My name is John Dulac. I work in the Energy Technology and Policy Division at the IEA, particularly looking at global buildings energy demand to 2050 as part of our Energy Technology and Policies Perspectives publication. Just to give you an overview of what we are looking at the IEA in terms of building energy demand, globally you can see since 1990 that buildings' final energy consumption has continued to increase at a steady pace. This is the case for pretty much all countries. There's only a handful of countries that have actually managed to reduce energy consumption in the building sector since 1990. And then there are some interesting trends in terms of energy efficiency in the building sector, depending on how you define energy efficiency. Typically, one of the primary indicators for energy efficiency in the building sector is energy per square meter or energy per household or per person. And as an example, you can see here that in both the services and residential subsectors, the average energy intensity in terms of kilowatt hours per square meter has improved since 1990, but this is largely due to building energy codes in mostly developing countries since the 1990s, whereas in many developing countries and emerging economies like Mexico, energy consumption per square meter has continued to increase as demand for energy services in buildings have increased. In Mexico, as you can see in the second slide, energy consumption has continued to increase at a relatively rapid pace since the 1990s. In terms of final energy per square meter, it has improved in the residential sector. This is due in combination to a lot of energy efficiency improvements in end-use equipment, as well as a reduction in the amount of traditional biomass use per household, which you can see in the bottom in green here. This is normal, obviously, as household wealth in Mexico continues to increase, that many households are shifting away from traditional use of biomass, which is very intense, to modern commercial fuels like natural gas and electricity. But conversely, as we can see on the top wedge here in blue, electricity consumption in the building sector in Mexico has increased considerably since 1990. And while electricity relative to biomass or fossil fuels is typically very efficient, it does have one major implication on the energy system in Mexico, largely and namely that being that it requires considerable production of electricity from the power generation sector which is quite intense in practically all countries, and poses a real concern for meeting long-term energy efficiency and carbon abatement targets for Mexico and globally. What's also quite interesting in Mexico, the second line here on the top is the energy consumption per square meter in the services or the non-residential subsector. And obviously, as commercial services in Mexico, as well as increased development of public buildings, hospitals, and other commercial spaces have continued to increase, and particularly as energy service demand have increased, the trend is actually the opposite from the residential sector, where the average energy intensity per square meter is still increasing. In terms of the split of the energy consumption in Mexico and Mexican buildings, you can see here for the residential and non-residential subsectors that water heating in particular is a major demand in Mexico and will continue to be. Mexico obviously is relatively moderate, if not hot and humid climate compared to many other countries in the Northern Hemisphere, which means that space heating demand is not huge, although it's important, and water heating demand, both because of the use of traditional biomass, as well as the share of water heating relative to other end uses, is significant. Space cooling is rapidly growing, as you know, in Mexico, and we expect it to continue to grow rapidly. And other end uses, for example, cooking, which is again largely tied to the use of biomass, continue to play an important role in buildings, although we would expect these shares to change as well. Shifts away from biomass use continue to. Conversely, demand for thermal comfort, and in particular for hot water and cooling, are expected to continue to grow rapidly as wealth and, again, demand for energy services and comfort continues to increase. Looking forward in a business-as-usual scenario, or what the IEA refers to globally as a 6°C scenario, in other words, an energy pathway that would put us on track for a 6°C average global temperature rise by 2050. And in Mexico, this means roughly 150% increase in energy demand, where across the end uses you can see here in the bottom orange and red wedges that cooling demand in particular is likely to increase significantly in Mexico. Again, this comes back to thermal comfort. Water heating demand also is expected to increase considerably, again, because of demand for comfort and energy services. And lighting and appliances are also expected to increase, although less rapidly, as household ownership of appliances continues to increase, and as the use of useful energy for lighting, so the amount of lighting asked for per square meter continues to increase, again, because of increases in demand for energy utility or energy services. What we would like to see happen in Mexico, putting it on an energy efficiency pathway that we define here at the IEA as a 2°C scenario, in line with global ambitions to limit temperature rises to 2°C or below, is the bottom line you see here, which is roughly a third less than the 6°C scenario in 2050, and slightly above energy consumption today. For a rapidly emerging economy like Mexico, it's normal that we would expect energy, final energy, to continue to increase. But at the same time, we know that we can do this much more efficiently. And this obviously has implications on the broader energy sector and economy in Mexico, as it means reductions in the use of fossil fuels for more efficient electrical end-use equipment, which obviously has implications for things like local air pollution. It also means significant reductions in the amount of electricity demanded in Mexico under the 2DS, which again has implications for the power generation sector, meaning that if we were to pursue this energy efficiency pathway, we would need to add less capacity, especially peak load capacity for space cooling in the building sector, in the power sector, which means significantly less investment in power infrastructure and grid utilities in Mexico. And again, the bulk of these reductions are coming from the two principal sources of demand in Mexico, which are heating and cooling. And we know that through building energy codes, as well as through available cost-effective building technologies, which I will speak to next, that we can significantly reduce the demand for heating and cooling in buildings. Now, from an energy efficiency perspective, what's quite interesting about the building sector globally, and this is certainly the case in Mexico as well, is that the building sector remains largely the single largest source of energy efficiency potential that remains untapped. And you can see here a report that the IEA did in 2014 looking at the different energy efficiency opportunities by sector, where of course buildings is the largest unrealized energy efficiency potential globally. This is largely because of a failure both from a market perspective and a policy perspective to drive energy efficient technologies in buildings. Starting first and foremost with building energy codes for building construction and heating and cooling in buildings, and then of course strong policy pushes for energy efficient equipment. And what this means in terms of real impact, to give an idea of the size of this energy efficiency potential in buildings, is roughly $300 billion a year in terms of energy savings potential. So this is not insignificant globally, and again, it for the most part is involving already available cost-effective technologies that we simply have not tapped into in the building sector. The other major driver for energy efficiency in buildings is of course what we call the IEA energy efficiency prosperity, or the multiple benefits of energy efficiency improvements. And this can be things, again, like improvement in local air quality, increased energy security, reduction of greenhouse gas emissions, as well as more affordable energy and energy access, especially in developing countries, and increased household income because of less money spent on energy in the building sector, which of course has implications for the broader economy in countries. And taking these into account, we have a much more holistic picture of why energy efficiency in buildings is not just important to reducing energy demand and the carbon impact, of course, from emissions in the building sector, but also the numerous benefits that come from these multiple benefits of energy efficiency action. So with that, we'll speak now more to heating, cooling, and water heating opportunities in Mexico, where again, these are the bulk of the energy efficiency opportunities and savings in the building sector. For those of you who are interested in other building end uses, such as lighting and appliances, we have done previous webinars on these topics, and the information can be found online. On that point, it's also possible to find practically all of the information that we are sharing with you today for free on the IEA's website if you're interested in downloading any more information. So, looking at the building sector, and in particular heating and cooling and their relationship to the construction of buildings, understanding the lifetimes of building stocks is critical to understanding energy efficiency opportunities in buildings, where in particular building shells or building envelopes, that is to say the construction of buildings, windows, roofs, walls, foundations, etc., typically have very long-lived lifetimes. In many countries, we're looking upwards of 50 to 100 years, and in the services sector or the non-residential sector, perhaps 30 to 50 years for many building types. And of course, when we're looking at these investments, we want to avoid locking in inefficient building energy efficiency decisions. So, for example, making sure that we get in new construction energy efficient building envelopes, so that in 10 years or 15 years, we are not faced with the decision of how to improve the efficiency for a building's asset that still is less than half or even a third of its potential lifetime, because of course these are very expensive investments. So looking across the different products in both the building sector and then also relative to some other sectors, you can see that building stocks on the bottom here, in other words, the building envelope, the actual building itself, are probably one of the longest lived assets in the energy sector. where some of these shorter products, for example, light bulbs, obviously are replaced much more frequently. What's also interesting is that buildings relative to most infrastructure, so for example distribution pipelines, power stations, are also still significantly longer lived than many of those assets. And yet buildings in this sense probably are the one area that is the least treated in these discussions about long-term energy efficiency potential and investment. Now, to give a better example of what we mean in this area, I'm giving you an example of the global residential floor area growth and what we would expect to happen between now and 2050, and why getting energy efficiency right in building construction is so important looking forward. So you can see here today the global floor area in square meters, and where we would then expect this to go to 2050 relative to increases in household income and the number of persons per household in the building sector. And typically speaking, what happens is something in this building stock, and I'll come to this point in a second, disappears because of obviously demolition in the buildings, and even in a business as usual scenario, some moderate renovations of existing stock. And then of course, looking forward, especially globally and in emerging economies like Mexico, a significant portion of new construction. And how do we build those buildings? How efficient do we build them? Now, in a business as usual scenario, so our 6DS, we typically expect that roughly half, and this of course depends on the country, the level of enforcement and the presence of building energy codes, but globally speaking, roughly half of the building stock is probably compliant with building energy codes, whereas the remaining half of new construction is either not compliant or does not have an applicable energy code. And when you look at this in terms of the total square meters, again remembering that space heating and cooling are globally the largest energy demands in the building sector, this becomes really important because essentially it means that half of the new construction that we expect between now and 2050 will not be compliant with energy codes or not have any energy codes applied to them at all, meaning that those buildings will be consuming much more energy for heating and cooling than they could have had we put those energy codes in place and enforced them. In terms of the existing stock, and this of course applies to certain areas in Mexico where substantial buildings have already been built in terms of total square meters, we want to make sure that we are treating these buildings and when renovating those buildings, making sure that we address to the most cost-effective potential the energy efficiency opportunities in those buildings. So in a 2 degrees Celsius scenario, and again this is globally, what we would expect to happen would be increased use of building energy codes across all countries, and over time making those energy codes more stringent, and also putting in place the infrastructure to enforce the compliance of those energy codes, both within the design, the construction, and the post-construction phases. And we can speak more to this point later on how to develop and implement building energy codes. And then, of course, making sure that the existing building stock, or the bulk of it, gets refurbished by 2050. And again, taking into account into average building lifetimes, you can see here that roughly 80% of the world's building stock already in place today will still be in place in 2050. And having said that, if we don't address energy efficiency retrofits in those buildings, we are very unlikely to meet the energy and emissions targets for the global building sector. Now, as I mentioned, for emerging economies in particular, and especially Mexico, targeting new buildings and energy efficiency in the development of new buildings is critical, where we would want to go to existing construction practices, which in most parts of the developing world and even in many developed economies are relatively inefficient. This might mean things like single pane windows that are constructed on site, very low or no levels of insulation, high air leakage, to typical building codes that exist in most advanced regions today. This would be things like low emissivity double glazed windows, and I'll come back to the point on low emissivity in a second, high levels of insulation, and lower air leakage compared to traditional construction. And what we want to do is move this market, particularly for new construction, towards near zero and zero energy buildings, where we have high levels of insulation and air sealing. We are using advanced window products, including dynamic solar control, to take advantage of opportunities like when we want the sun to influence heat in buildings and when we don't want it to influence heat in buildings. And also optimizing building design, where, of course, in most parts of the world, there has been a significant movement to the use of all glass or highly saturated glass surfaces, especially in the commercial sector, and where buildings, because of urban development and urban design, often are not optimized relative to their environmental situation, and where we also don't typically design buildings, for example, to take advantage of natural cooling, natural heating, natural daylighting, and if these were integrated into building design, we could significantly reduce the final energy loads in buildings. In terms of the role of building envelopes, so again, building construction in the energy savings potential for heating and cooling, our model assessment finds that more than 2/3 of heating and cooling energy reductions are likely to come from building envelope improvements. And again, this is only possible through the development and enforcement of rigorous building energy codes that address building construction and in existing buildings seek to improve those efficiencies to the most cost-effective point possible. So in terms of the components, once we've constructed a building, and my colleague Brian will come back to some of the policies related to implementing and enforcing building energy codes. Once we have these buildings in place, of course the question is, well, then how do we provide the energy utility or the energy services for demand in buildings? And with regards to heating and cooling, it's critical that we address, especially in Mexico, the key elements related to the heating and cooling loads in buildings, which of course is in Mexico probably first and foremost cool roofs, so ensuring that buildings are not absorbing heat from the sun, which drastically increases the demand for cooling, that we're also using insulation and advanced window products to, again, treat the environment and radiation from the sun in a way that reduces the need for cooling in buildings, and also treating air leakage, which in most countries can be a significant contribution to heating and cooling loads. It's also probably one of the most simplest ways to address heating and cooling. And looking across some of the reasons this becomes very important in Mexico is obviously Mexico is highly urbanized, and the increased use of cooling in buildings in Mexico is not only a driver, is not only influenced by the sun and the climate in Mexico, but actually is also a driver of the demand of cooling in buildings as the urban heat island effect. So both the radiation of heat from the sun back into the urban environment, as well as heat produced by buildings that is then released into the environment, continue to increase the demand for space cooling in buildings in Mexico. And we know that existing cost-effective technologies and building design can significantly reduce the impact of urban heat island in cities. So, as I mentioned, one of the simplest and most cost-effective technologies for Mexico, and for that matter, many parts of Latin America and other warm climates throughout the world, is cool roofs, where the design of a roof to reflect heat or reject heat from the sun can significantly reduce energy loads for cooling in buildings, where a traditional roof that often is asphalt or another dark product, for example tar, absorbs typically between 90 and 95% of the heat from the sun through solar radiation. And through the use of cool building products, we can reduce this to less than 20 to 30% of heat absorbed from the sun in buildings, where obviously this is a significant difference and can drastically reduce building energy demand for space cooling. Another critical product, coming back to low emissivity or low E windows, is the use of windows to, again, reject heat or, when necessary, keep heat in buildings, depending on the climate, of course. And the bulk of the world's windows, and this includes countries like Mexico, are typically single-glazed or maybe double-glazed aluminum frame windows that are not exceptionally efficient, that can be significantly improved through the use of double-glazed low-E windows, and in cold climates, so less the case in Mexico, the use of triple-pane windows. Now, what is low emissivity or low-E windows? So most of you, I'm sure, are very familiar. All of you are familiar with single glazed windows. This is a pane of glass. It's often made on site and typically has either a wooden or an aluminum frame, or in many cases it might even be concrete surrounding the glass. And we move towards double glazing, which is increasingly common in many countries across the world without a low-E coating. And so essentially this is just an air gas that might have an inert gas inside between two panes of glass. And so there's a relative level of insulation because of this air gap between the two panes, which helps to reduce some of the heat loss or heat gain in buildings. But it doesn't do anything about the reflectance and the heat gain from the sun. So a low-E coating, and this depends on the climate, so actually it depends which side of the window you put the coating on. But essentially what a low-E coating does is reflect the near-infrared light from the sun, and it then rejects, depending on the direction, the long-wave radiant heat either to or from a building. So for example, in a cold climate, which is the illustration here, what this means is that we would accept the visible light, which is obviously important in buildings, and then reject the near-infrared light, which would then reduce the the cooling load in buildings, but at the same time it would also reject the heat back into the room so the radiant heat leaving the building through the window, which helps obviously to save on space heating. And if you reverse this, essentially what happens is that for hot climates, so you can see the black line here below, is that we would essentially allow more rejection of heat from the building and less infrared light rejection on the exterior shell. This is a very simple technology. It's cost-effective in most markets. It's usually more about market conditioning and working with technology providers to get these products on the market, but they can significantly reduce the demand for space cooling or, in cold climates, space heating in buildings. And again, the critical point here is that we continue to increase the amount of window surfaces in buildings, especially commercial buildings, and we therefore need to make sure that when we're using windows in buildings that we are using the best technology available, since this can have a significant impact on heating and cooling loads. There are also advanced products, and part of this can be combined with either traditional or advanced shading. So obviously in a warm climate like Mexico, if we can prevent the radiation from the sun, and this is obviously in many of the traditional design of buildings in Mexico with porches or natural shading on the exterior of the building, can make the building feel significantly cooler on the inside. This can be paired as well with advanced products like integrated solar facades, which you see here on the left, to take advantage of energy efficiency and renewable technology potential in buildings. It also can be advanced window products. So the two pictures you see on the right are actually of dynamic glazing, where the tint of the window can be changed electrochromically to allow for less light to enter during cooler hours of the day and less light to enter in terms of the radiation, but not the visible light, during warmer hours of the day, which again can have a significant impact on building energy loads. These are advanced products. We hope to bring these to market in especially warmer climates over the next 30 to 40 years, but for the most part they're still very expensive. As I mentioned, traditional techniques like the use of exterior porches or simple shading on buildings can also be used and be very effective. In terms of insulation, this again depends on the climate. We know that globally insulation is not where it should be. In cold climates, obviously, we would want to move to the right of this figure where we increase insulation levels. But across the world, we would want, especially for temperate and warmer climates, to move to this 0.5 to 0.8 U value range, which is essentially the watts per square meter Kelvin that is demanded for heating and cooling. And this again applies to building energy codes, both the development and implementation of those codes as well as the enforcement. And by addressing building construction, well, first building design, building construction, and then evaluation of the building post-construction, we can do a much better job at getting buildings down to acceptable, cost-effective levels of installation that drastically reduce heating and cooling demand. The last point, as I mentioned, is air sealing, which is extremely cost-effective. It's very simple to do. There are different technologies that can be used in this area, from things like polystyrene foams that can be sprayed to your traditional paneled insulation or fiberglass insulation. There are also increasingly in many markets very inexpensive technologies that can be used to scan buildings. So, for example, you're seeing here in the right picture an example of a scan of the heating intensities, and the areas, of course, that are orange to red are losing heat, and so it's important to address these. And conversely, in a warm climate, the same is also true, that we would want to make sure that we are rejecting heat from the outside and keeping the inside of a building cool. Now, in all of these cases, whether it be windows, air sealing, or insulation, especially in warm and hot, humid climates, there's also a concern for humidity in buildings. And this is not only a building design question, but also a heating ventilation issue. We want to make sure that as we build these buildings and make them more airtight and better insulated, that we're not also at the same time creating an interior humidity problem, which could lead to issues like mold in buildings. And so designing the building properly to have the right ventilation, which can either be natural or mechanical, is important to make sure that the building is not also energy efficient, but at the same time is also healthy and safe to live in. As a last example, which does apply again to some building types in Mexico, building retrofits are critical to achieving global energy efficiency and carbon targets in the building sector. And there are lots of cost-effective ways to address this in most building types, save perhaps some of the historical monuments that are more difficult and cost-expensive to renovate. But for the typical building stock, whether it be a residential building as pictured here or commercial building, it is often very cost-effective to use simple measures like exterior insulation that is shown here, air sealing, replacement of windows, replacement of roofs, to drastically reduce energy demand in existing buildings. And as another example of what is a building energy renovation to what we traditionally call a near-zero energy building, this is taking place is a passive house in Germany. It's an apartment complex where, as you can see from left to right, what they have done is added insulation, replaced the windows, replaced the roof, added solar panels to the roof, also added amenities like the porches you see on the right, which at the same time are also providing shading to the building. And these are not only drastically reducing the heating and cooling loads in the building, but at the same time, they're also increasing the value of the building because you've now made an investment that makes the building not only more attractive, but also a healthier and more efficient place to live. And so taking these into account, again, the multiple benefits, the energy prosperity of building energy efficiency measures can really sell the case for energy efficiency retrofits in existing buildings. Now, finally, the last question, and I think this is particularly important for today's conversations about Mexico, are the technologies we use when we do have to provide heating and cooling in buildings. Now, the direction we are encouraging for all countries, of course, is to bring heating and cooling demand as low as possible through building envelope measures. But of course, heating and cooling will always be an issue in buildings, and there are several technologies that are extremely cost-effective and energy efficient that are already on the market today, and we have across these technologies recommendations that we think are particularly applicable to Mexico and other warm climates. Now, the first is heat pump technologies, and I've given two examples here where electric resistance heaters, these are often called toaster grills, that essentially are taking electricity and converting it into heat. These are technically speaking efficient because it's an electrical conversion, so it's 100%, but they can be significantly more efficient using heat pump technologies, which typically have efficiencies of 250% or more. In some cases, in the residential sector, using small-scale heat pumps, the efficiencies can be as much as 600%. In the commercial sector, because of scale, using large heat pumps, it's actually possible to achieve heating and cooling efficiencies with efficiencies that are above 1,500 or 2,000%. So obviously this is a drastic improvement compared to traditional electric resistance technologies. And in Mexico, another heating technology not shown here that's very common are oil boilers and gas boilers, where these always have an efficiency below 100%, typically in the range of maybe 75 to 80%, and for gas condensing boilers, maybe 95%. But again, these are still significantly lower than what is possible with heat pumps. Now, to explain how heat pump works, you can see in the diagram here on the right that effectively what a heat pump does is it takes a heat source. So for example, in the case of cooling, it takes the heat that is within the building, it is using an exchanger and a compressor to then extract that heat and reject it on the opposite side, so outside of the building. The same is done, so it's the reverse situation for space heating, where a temperature gradient is removing heat from the exterior air, passing this through a heat exchanger and a compressor, and then putting heat into the building. And the reason this is so efficient is that it is essentially dependent on the delta T, so the change in temperature. And in moderate to warm climates, heat pump efficiencies are, generally speaking, extremely efficient because the temperature gradient is not that big relative to cold climates like Norway or Canada, for example. Now, as an example of some of the products that are on the market and the typical efficiencies that we see, and again, these are small-scale heat pumps that are traditionally used in the residential sector, you can see that for almost all of the heat pump examples we've shown here, that they're typically above 300%. And again, in warmer climates where the delta T for the temperature exchange is typically smaller, the efficiencies can be even higher. There are also different heat pump technologies. The most common is an air-to-air, so an air source heat pump where it is taking heat from air and rejecting it to air. There are also air source heat pumps that use water. So, for example, they are either taking heat from the air and using it to produce hot water, or they are taking heat from an external water source, like a river, for example, or a lake, and using that to either cool or heat a building. And then there are ground source heat pumps, which are typically speaking more expensive because it's a much larger infrastructure, that are taking energy from the ground, so heating and cooling from the ground, and can be very effective. And again, this is largely due to the scale. So we're increasing the size of the equipment and we have better efficiencies. Now, there are also heat pumps for water heaters, and a very common one, especially in Japan, pictured here, is the EcoCute. These, again, typically have efficiencies above 150%, and in some markets 250%. And compared with a traditional gas boiler, which is maybe 70 to, again, 95% for condensing gas boilers, electric resistance at 100%, or an electric resistance water heater that then uses storage, which is usually 70 to 80% effective, accounting for the storage. Heat pumps, again, come out on the top as being significantly more efficient. And again, these technologies are available. It is more a question of market conditioning, getting these products out into the market, creating the right incentives and policy levers to ensure that consumers are buying these products. Now, I mentioned most of our publications are available online for free. If you visit our website at www.iea.org. The first and most applicable to the work that we do with regards to technology in buildings was a buildings book that we released in 2013 called Transition to Sustainable Buildings. This is essentially a practitioner's guide to the different technologies that exist across the end uses in buildings. We also released a technology roadmap on energy efficient building envelopes, where again building envelopes play a critical role in achieving energy efficiency in buildings. We also have technology roadmaps on heating and cooling equipment, solar heating and cooling, as well as policy pathways, which are a step-by-step guide walking you through the development, implementation, monitoring, and evaluation of policies for building energy codes and certification. And again, all of these are available on our website. So I will pass it now to my colleague Brian Dean, who will speak to you more about the policies for energy efficient buildings.
Okay, great. Thanks, John. All right. Let me start off first by saying one of the other publications that the IEA developed is Energy Efficiency Policy Recommendations. And we like to go back to this as a starting point for framing our policy discussion. And we actually did a presentation on this last year, or sorry, in November of 2014, where we walked through all of the policy recommendations across all the sectors. In addition to that, there was also work done for the policy recommendations with Latin America and the Caribbean. And so if you go to the website at the bottom of this page, looking for the energy efficiency policy recommendations, you'll find both the original 25 policy recommendations and the one for Latin America. The 5 different policy types that we typically have for the building sector is mandatory building energy codes, minimum energy performance standards, aiming towards net zero, like John had mentioned, improved energy efficiency in existing buildings, labels and certificates for buildings, and then energy performance of the actual components, the technologies that John just walked us through. For Mexico, one of the other IEA publications looked at the technology and policy priorities. This was a couple of years ago, and what you see here is consistent with what John has been talking about. There's a priority for technologies that reduce the cooling loads and also the solar thermal side. And then on the policy side, both the building codes and the appliance and equipment standards. So I think a lot of these messages are quite consistent on opportunities for Mexico. That then led to us to work with SENER and CONUEE over the past year and a half, where we looked at energy efficiency policy recommendations for Mexico with a particular focus on buildings, space cooling, and building energy codes. Through that effort, we had 3 major sets of recommendations around governance, capacity building, and policy and program recommendations. So 20 total recommendations for Mexico. And one of the areas that we're currently working on with SENER and CONUEE and others is pulling together a roadmap for building energy codes and standards. And this roadmap is intended to be a means for looking into the future and making sure that the building energy policies are coordinated in a way that will create energy efficient buildings moving forward. Now we do this building energy codes research globally, and we look at the coverage and the types of codes that are developed globally. And what we find is that there are opportunities for lessons learned from various countries and examples of well-developed building codes. And so we bring this type of information into the discussion. But what we also find is that sometimes the development of good building energy codes is not the whole picture. So in terms of our roadmap, we're looking at going beyond and making sure that there's strong local adoption and enforcement of the building codes, going beyond just the development of the code itself. Now, if you're looking for information that we store in a database, you can go to the iea.org BEEP, B-E-E-P, our Building Energy Efficiency Policies database. We are continuing to add to that database every year based on information that we get from countries around the globe. And for Mexico, what we worked up for the building energy codes was a 4-part governance of building energy codes. And what we find with that is that in terms of the lead organizations for each of these 4 parts, so plan, adopt, enforce, and review and update. For both the plan and the review and update, the two on the left, we see that there's a strong need for national support, ensuring that there's harmonization across an entire country. So in Mexico, that's having strong support both from SENER and CONUEE to make sure that there's building code harmonization across Mexico. However, once you get to the right side, the adoption and the enforcement, it's critical that the local municipalities, the local organizations are taking strong ownership of this and making sure that ultimately at the end of the day, the buildings are energy efficient and meeting the policies and the codes in place. In addition, this is a document or an image that comes out of our Building Energy Codes pathway that John mentioned. And there is guidance in here regarding how much enforcement can be done at each stage of the construction process. So this is another way for local jurisdictions to ensure that their processes for checking compliance of building energy codes can be effective. Now, in addition to those policies, there's also a large issue in terms of energy renovations, and it's often much easier to set up policies that control new buildings. However, we can set up good policies that can impact the energy renovation process. Now, from a government perspective, that would be setting up a timeline for what the government would like to achieve. Also, minimum energy performance standards for the building technologies themselves, so the envelope and building systems. Often energy audits and a rating or certification process could help identify particular upgrades that should be done in buildings. And then once we get to the bottom here, you'll see the incentives and the financial options. Countries like France and Germany have done a great job of setting up tax policies and financing policies that are putting billions of dollars of renovations into the market every year. Now, also training for energy retrofit services can go along with the energy ratings and certification as well. And then the very last item is actually making sure that the government does its part, so leading by example and having improvements in the public sector buildings. In terms of the actual technologies, there's the opportunity for policies that improve the windows in terms of both the quantity of windows in buildings. As John mentioned, there's a trend towards having fully glazed buildings. If those buildings are going to be fully glazed, well, then they're going to need to have really good windows to make sure that it's not like a greenhouse absorbing all of the solar energy. Now, in terms of heating and cooling equipment, having minimum energy performance standards for the heating and cooling systems, having labeling and product incentives that encourage people to purchase these high-efficient equipment, and then train the trainer, making sure that when the engineers are specifying it or the architects are looking to make design changes to buildings, making sure that they're doing it in an energy-efficient manner. And then for energy management systems, there's opportunities for having incentives for both the energy savings themselves and also in the design requirement process as well. So why do we do all of these policies? Well, if we do it in a coordinated manner, what we're going to see is that the market will transform faster. So in this particular example, you see that a typical commercialization of energy efficient products for buildings could take 20, 30 years, and we see actually some take even significantly longer than that. However, if you put policies in place at the right time, you can continue to accelerate the adoption of these technologies in the market. So having an improved 10 to 15 year cycle instead of 20 to 30 years. So that would help move us from a 6-degree path to a 2-degree path. So we like this image from the World Resources Institute. It shows that if we work together with each of the stakeholders and we put together a series of policies that will enable a market for energy efficiency, so codes and standards and other targets and awareness items, we'll be able to get over this river of barriers, as the image shows, and ultimately have energy efficient buildings. So that leads me to the point of collaboration. I want to talk through a series of the IEA's technology collaboration programs that relate to buildings. There are actually 5 of them, and you can see the website there. You can click in through that, and you can get to each of the websites for each of the collaboration programs. The largest one of these is the Energy in Buildings and Communities, and that has a series of tasks that I'll show on the next slide. But it's working most broadly on energy issues in both buildings, but also at the city and urban level. Next one is heat pumping technologies. I think those 2 are probably the most interesting for Mexico. However, there's also the 4E, which is the energy efficient end use equipment. That's appliances and technologies that go into buildings. District heating and cooling, which is the services that can be available for building technologies to attach to do both heating and cooling. And then the last one is energy conservation through energy storage. So these are the 5 buildings collaboration programs. For EBC, which is the Energy in Buildings and Communities, I have these listed from the most recent at the top and the older annexes at the bottom. All of these annexes are still active projects. The newest one, energy epidemiology, which is looking at energy data to better understand buildings, or as it may be, better understand the health and operation of these buildings. There was a workshop in Mexico just a couple of weeks ago that explored this issue with Mexico. And then there's a series of these other technical research projects that look at a number of areas ranging from cooling, insulation, behavior, communities. There's a range of topics that are quite interesting and could help in your policy development and program design and things like that in Mexico. For heat pumping technologies, this is also pretty wide-ranging in that it looks at industrial heat pumps as they are integrated into district heating and cooling, heat pumps for domestic hot water, as John mentioned. This is one that I think could be a huge opportunity for Mexico. Hybrid heat pumps, supermarket heat pumps, and also fuel heat pumps. So that's the webinar for today, and I think at this point we'll get to some questions. And I know that there's some that came in online, so I'll hand it over to David.
Thank you, Brian and John, for a really interesting presentation. We have about, I think we've just gone slightly over time, but we also started a bit later. So I think we'll have another 5-10 minutes for questions, and there's some questions that have come through already. But again, if you have any questions, please do send them through the question pane, either in English or Spanish, and we'll try to go through them and answer them. The first question maybe is what new building technologies are best for Mexico? I don't know if one of you want to answer that.
Well, I think Brian made a very good point in the last slide here, and this was discussed in the technology discussions, that there are effectively 3 areas that we see as critical priorities in Mexico. The first is building envelopes, so this is technologies for cool roofs, windows, air sealing, and insulation. From an equipment perspective, for heating and cooling, heat pumps and solar thermal water heaters are a real opportunity in Mexico, especially given the warm climate in most of Mexico. And the last, since biomass, but we didn't discuss this very much, is still rather big in Mexico, is more policies than technologies of helping rural households move away from traditional use of biomass to either more efficient biomass technologies such as clean cook stoves, or eventually to commercial fuels for cooking.
Thank you, John. Then the other question we have is how can Mexico move the buildings market towards an energy efficient future?
I'll take that one. So I think one of the ways that we see this is, we want to create an enabling environment. So we want policies and programs to be developed that enable private investment and enable people to make wise decisions on energy efficiency in buildings. That's a combination of the technologies and policies that we've been talking about today. That's a combination of mandatory and voluntary policies. And ultimately, I think creating harmonization across Mexico, further than that, harmonization across North America on policy types, on technology types, will actually help reduce costs for technologies, and also can enable more consistent design decisions through improved capacity building, because if we have harmonization, we have consistency across multiple of markets, and the education follows along with that.
We're now getting hundreds of questions at the moment. We'll try to answer as many as we can in the next couple of minutes. The next question we have is, what's the average payback time for residential retrofitting in countries like Mexico? So maybe, I don't know if you have any examples in the U.S., similar climate, where those have been done. I think that might be an interesting.
Well, I think as Brian mentioned, one of the critical pieces, and this makes a major difference in the payback times, is creating the right market conditions and policy frameworks in support of building energy retrofits. This also applies to new buildings, where obviously if you don't have the incentives and policies in place that push the market in the direction of energy efficiency technologies, it's more expensive to make those investments. Now, in markets where established demand is already in place, so for example, if we compare to the United States, where in most regions of the United States, double paned low-E windows are the standard now after about 20 years of market development. These are effectively as cost-effective as installing a regular window now, because the market has reached a point of maturity that this is standard practice. So in Mexico, creating the right policy framework and the right incentives to get the markets moving in a certain direction, especially for building envelope products, will make a major difference. Now, depending on the building type, the payback period can be different. Obviously, in commercial buildings, the paybacks tend to be shorter periods because of the size of the building and the question of scale in terms of the investment. And in the residential sector, depending on the technology types, as I mentioned, some are very cost-effective and quick to do. This can be, for example, cool roofs. So even painting the color of a roof to a light color or to a color that reflects the sun's rays can be done very quickly and very cost-effectively, where obviously larger investments like insulation in buildings, replacing all the windows, can be more expensive. But again, putting in place the right voluntary and mandatory measures creates the market conditions that shorten these return periods for the investment.
Thank you, John. We've got a series of questions asking about subsidies and types of programs available in Mexico for energy efficient in buildings, replacement of equipment as well. So I particularly recommend looking at the website from CONUEE, which has a lot of information about the different programs on energy efficiency in buildings. There's also for FIDE, which is the trust fund for energy savings. There's also in Infonavit and also through SEDATO you might be able to find some of those information. Unfortunately, we don't have time to go through all those questions. Another person was asking particularly about the importance of natural ventilation, so I was wondering if you want to highlight a bit about that.
So natural ventilation is actually one of my favorite topics and what I did my master's thesis on, so I'd be happy to answer that one. I think that natural ventilation is really critical as a way of saving energy, but what we find is that as John talked about, air sealing is really critical. So what you want to do is you want to air seal buildings so that you get rid of all of the uncontrollable airflow. And then what you want to do is then you want to add in the ability to control airflow, and that could be through windows, it could be through fans, or doors and other openings, basically. But we do see that natural ventilation is a great potential for, particularly in moderate climates or in shoulder seasons between winter and summer, as a way of using no mechanical heating or cooling. But doing it in a way that's controlled will actually be healthier, so that you know where your airflow is coming from. In the past, a lot of times people have considered natural ventilation and air leakage as one and the same, but they're very different. So reduce the air leakage to as low as possible, but then enable natural ventilation either through stack or cross ventilation.
Thank you, Brian. I think we will go to the final question. One person asked about the importance of ESCOs and helping move to energy efficient buildings, and it's worth mentioning just before I pass on to John and Brian that CONUEE has been working on this aspect, looking at ESCOs and looking at developing materials, contract templates. So again, it's something that's available on the CONUEE website if anybody is interested. But you guys want to mention something on the importance of ESCOs?
Yeah, I think ESCOs are a very interesting opportunity, and they've really, the presence of them in discussions about building energy efficiency investments has increased significantly in the last couple of years. I think largely because people see this as a way to get money flowing in energy efficiency investments in the building sector. It is not the only way to address financing for buildings. There are lots of ways, and there's more information about this on our webpage under the building policy publications. But ESCOs are particularly interesting because they can, if designed correctly, bring the right players around the table to affect significant deep energy renovations in buildings. So for example, there are some cases in North America and in Europe where ESCOs have been developed putting together building constructors, building material providers, municipalities, and the financing sector to develop packages for buildings that can effectively achieve energy efficiency investments at or below cost for building owners. One recent example, for example, here in Europe is in the Netherlands. It's a project called Energy Sprong, which translates roughly to Energy Leap in English, where again the Dutch government has brought together building constructors, material providers, banks, and municipal authorities to design a package of building energy efficiency measures that can be applied across public housing, so targeting in particular a sector of the market that doesn't often have money for these type of investments. And the reason it works so well is not just because they've brought them all around the table, but that they've designed the energy efficiency improvements in a way that it can be done at scale. So again, this reduces the costs, in particular for the constructors, and for the building manufacturers, and that at the same time is supported by the government through a bonding process that gives it long-term foresight, so it reduces some of the risk in the market and gives investors more confidence in the project, and has now improved something like 110,000 households in the Netherlands, bringing them down to near zero energy levels. So these are a real energy efficiency gain that is designed in a way to be effective, but again requires creating the right framework and condition and the right players around the table to make it effective.
Thanks, John. That's a perfect example, and I think with that we finish our presentation and our webinar. Thanks to those that really stayed a couple minutes longer. We'd like to thank you for your attention and participation in today's webinar. The presentation, a lot of people have been asking, should be available by the end of this week on IEA's YouTube website, and we'll make sure to send you the link as well as the PDF for the presentation. So please feel free to share it with your colleagues. For us, it's been a real pleasure to conduct this webinar, which we hope to find you found useful. We'd also like to thank again SENER and Anna Lepore, our IEA staff at SENER, for all their support and helping us organize these webinars. We'll continue to organize other energy efficiency webinars, with the next one tentatively on the 18th of May at the same time, which will cover energy efficiency indicators for policymakers and statisticians. We'll keep you informed, and please do not hesitate to contact us if you have any questions. Thank you very much.